Hello, ma'am. So my project topic is auxiliary learning as a step towards artificial general intelligence, and yeah, I wanted to write a research paper, so that's why it's a new topic. Like auxiliary learning is something that I coined the word, and so in auxiliary learning we introduce a new class called auxiliary class, and I'll just get back to that in a moment. So yeah, coming to the abstract, yeah. So basically. The main objective of auxiliary class, introducing a class called auxiliary class, is to provide neural networks with the ability to um, learn to distinguish objects similar to how humans learn to distinguish objects. Like when a baby is born, he or she would see a numerous amount of objects in front of him or her, and like the parents would tell him that this is a pen, this is a balloon, and she would learn to recognize a pen or a balloon, but at the same time, she knows that everything else in the room is not a pen or not a balloon, and those are different objects which she still needs to learn. So that's the aim of auxiliary learning. Like the neural network should be aware of the fact that there are a lot of objects in the real world which do not satisfy the predefined classes. Like the predefined classes are the normal classes that we have in classification. So, uh, like I wrote a research paper. Like I'm writing a research paper, and so for the project report, I tried to copy like whatever I wrote from the paper into this report. And so throughout the paper, I have been giving examples through the cat and dog classifier because that's like the most basic one, and it's actually a pretty industry standard. So I thought that would be a good example. Like the cat and dog competition on cable was really famous earlier. Yeah, so I thought that would be a pretty good example to give. And so like it's not specific to the cat and dog example. Like it can be expanded to any neural network, and like further it can be expanded to any classification problem itself. So yeah, and it does not I have to say the fact that it does not restrict itself to image data as well. So it's for classification. That's why I wrote it for my AI paper. Like it's on artificial intelligence and not on machine learning. So yeah, let's refer to it as an agent. Yeah, so let's think of the cat and dog classifier, for example. So if we give the cat classifier an image of a wolf, he would definitely most probably mistake it for an image of a dog. So like there will be a higher probability for he'll predict it to be a dog because of the higher probability. Like the probability values will be between 0 and 1, and the values for cat and dog that are predicted must add up to 1. So yeah, like he'll predict more than 0.5 for either one of them, and that's something wrong, right? Like we want our model, like okay, my objective is to be able to reach those years when we have artificial general intelligence and not artificial like narrow purpose AI or weak AI. So in order to achieve artificial general intelligence, it needs to be able to know like almost everything in the world. At the same time, we cannot teach it everything in the world, so it should retain the ability to be able to learn new things, and instead of like stating that he knows everything already. So yeah, that's literally like there's a lot of concepts behind auxiliary learning, and I have written most of it out in the paper, and then yeah, I put it in the report as well. So coming to the source requirements are extremely important because like I use multiple data sets to implement this paper, and so our memory is the biggest constraint here because like for building the auxiliary class, like okay, in case of like cat and dog classifier, will the auxiliary class will contain images of almost everything that is not a cat and a dog, like similar to how a baby sees things. So all those things are not a cat and not a dog. So yeah, our auxiliary class will be huge, and it will require a huge amount of memory in both our hard disk as well as our RAM. As in order to train the model, like we should have all of those images in a NumPy array, like in case of Python. So in order to say store all those arrays in our memory, our RAM has to be huge as well. So like 200 GB I mentioned is for like the first data set, is for the most commonly used subset of ImageNet, which is the ILSVRC 2012 to 2017 subset, and that has a size of 155 GB. And then I used the images for the cat and dog competition as well for building the normal classes cat and dog, and that has a size of around more 1 GB. And yeah, but those are the original data sets, and then we'll have to pre-process our images, and that takes a whole lot of hours. So we'll have to save the pre-processed images as well, because we don't want to spend all those time pre-processing the image for, or every time we make a small modification in our model. Yeah, like with 16 GB RAM itself, I was restricted to 1 by 12 to use 1 by 12th of the subset of the ILSRC dataset, and to resize the images to 65 by 64. So if I had a larger RAM, I could have tried it out with 120 by 128 or 256 by 256 dimensions, which could give much better results. But I did obtain significant results, and yeah, I'll come to the results at the last part. So yeah, it's very much important to how QDNN and CUDA properly set up, and that's because, like as I said, we are working with a huge amount of data, and it will take a lot of time to process. So it's better to have CUDA installed. Yeah. So the existing system, yeah, it's literally like every neural network is a narrow purpose neural network right now, and like even AlphaGo, like AlphaGo was a breakthrough, but it's restricted to playing the game Go. Yeah, it won't be good at playing chess. So that's like if we train it to play chess, it won't be good at Go anymore. So that's a weak AA, and like everything existing is weak AA, and my objective is to like make a step towards artificial generals, and yeah, like all those points. So yeah, okay. Something like a problem that arises with purely because of the nature of the auxiliary class is that, as I mentioned earlier, like auxiliary class will have a huge amount of data. So like during implementation, um, like okay, I have like three classes: cat, dog, and auxiliary. Auxiliary class, and another name for auxiliary class is others class. So cat, dog, and others. So the ratio of data available was in the 1:1:8.75. So I had like 8.75 times the data available for cat and dog, and that will cause an issue. But during training, because like the contribution from the auxiliary class is way much more towards the loss, so the loss will tend to modify the neural network as per to suit the auxiliary class. And the solution to that would be to use the weighted form of the categorical cross entropy. So here we have the WP for the positive weights and the WN for the negative weights, and this is an yeah, so WN and WP, like both of them add up to 1. And here we have the normal categorical cross entropy equation. Yeah, and another thing to note that while implementing it, we need to add this epsilon value inside wherever we are taking log, and that's to ensure that the probability doesn't become 0. So if the probability becomes 0, it will become a mathematical runtime error and cause our program to crash. So we need to add the small value, negligible value, in order to prevent that. And yeah, coming to the implementation part. Yeah, so yeah, like I'm not running it now because like the training of the model will take a lot of time. And yeah, so the model I used for training was a transfer learned mobile net. So yeah, transfer learning. So in case of transfer learning, like if we already have a model that's trained on a data set that is similar to our application, then we can just copy the weights from that trained model to our model. And our model must have the same architecture in order to copy the weights. And so since it's for this same application or the similar data set, the model will start from an accuracy of around 80% on training on the first epoch itself. So yeah, like target size, that's a constant, that's why I defined it earlier. And yeah, pre-processing of the like as I mentioned earlier, we are using a multiple of data sets. And yeah, so the ImageNet, as I said, was used for auxiliary class. um, and the most commonly used subset of ImageNet is the yeah, ILSVRC ImageNet large scale visual recognition challenge, and the dataset is available on Kaggle. Yeah, so yeah, and an issue with this dataset is that like the classes have a SYN ID. So the ID is a number and it starts with an N. So we have to there is this file called log synset mapping.txt, and that file contains all the mappings between the like the human readable description and the ID. So here they have given an exception example, like this ID will correspond to like tench tinka tinka, like that's name of a fish, I believe. So yeah, I have downloaded that, and that's like 155 GB, this ILSVRC dataset. And yeah, we have this log synset mapping.txt here. Yeah, so yeah, you get the idea, right? Yeah. So we have IDs and their human readable form, and I use this dogs versus cats dataset to um, get image data points for our normal predefined classes like cat and dog, and there's like 12,500 images in here. Yeah, so let's come back to the, yeah, this is the dogs versus cats, and it's provided as part of a competition. And I'll need this data set as well, because okay, an issue with the using the ImageNet subset for building the auxiliary class is that it has 120 breeds classes of that are different breeds of dogs. So we need to ensure that the auxiliary class doesn't have any image of a dog or a cat. So we need to remove all those 120 classes, and this data set has provided me with the names of all those 120 classes. So I use the names provided here, then the synset map to find out the class ID, and then remove all those class IDs. And so that's for the dogs, and then the ImageNet has images of cats as well. So I couldn't find any like pep material that said the number of species, specified the number of species. So I tried it manually, counted it manually, and I believe there's only 5 classes, and yeah, I had to remove those 5 classes. So yeah, the first thing to pre-process the ILSVRC dataset is to define the synset mapping. Yeah, and yeah, we define a dictionary here. And then this is the dog 120 dog breeds that needs to be excluded. And yeah, I had to manually type this because here it's an underscore separated test, and it's all lowercase, but in case of ILSVRC there's capital letters and it's not underscore, it's space. So yeah, I have to ensure that. And these are the 5 cat breeds: tabby, tiger cat, Persian cat, Siamese, Egyptian cat. And yeah, I'm just printing those values to ensure everything is correct. So yeah, after removing all those classes, we have a total of 875, like 125 minus like 120 plus 5, that's 125, and then the total 1000 classes minus those 125, so 875. Then we have to define our mapping between images and classes for validation set. And yeah, you'll understand that. So in case of the ILSVRC dataset, we have our train, and like we cannot use the test set because they haven't provided us the label, and that's because that's for a competition. And we have the train and validation sets. So for the implementation, but I use the train set for training and the validation set for testing. So yeah, here in case of train, we can see images are inside a directory with a name, with the name of the class itself. But in case of validation set, we don't have those subdirectories. But those subdirectories are provided in a, yeah, my laptop isn't loading that because there's a lot of images. Yeah, there's a lot of images. So yeah, like in this CSV file, it's mentioned which class each image belongs, like image name and which class. Yes, so that's what I'm doing here, the image ID. Then yeah, in the prediction string, the first value will be um, yeah, the class. So then yeah, building training data for auxiliary and auxiliary class. So yeah, this is the part where as I said, we'll be converting uh, yeah, loading all those images from all the selected classes and then pre-processing those images. And like as I said, it take a whole lot of hours to pre-process these images, so we'll have to save it. It's better to save it because we don't want to do the pre-processing again and again. Yeah, like complete processing image 4000, like, that's the output, and that's on auxiliary class. Yeah. And yeah, so this is the like total number of images in the train set will be like, yeah, 12 lakhs I believe. Yeah, 12 lakhs. And number of images in train set will be 87,500. Yeah, and that like 87,500 is because like we are using only 875 classes, and I'm taking only 1,000 images per class because of RAM constraints. Yeah, and fraction of selected images is only 6%. Yeah, so the test data will have the similar thing, but here for the train we could load images from directories, but here we have to load images directly. And the test set we have 50,000 images in the test set, but we are using only 43,000, and that's like 87% of the total data set. And yeah, so our train test split ratio is about 66%, and but yeah, we won't be using like that's the train test ratio between the auxiliary inside the auxiliary class itself, but the overall test ratio that I'll be using will be 0.8. Like we haven't completed building our data set. Yes, like we still have our dogs versus cats data set, which we are using for the dogs and cats classes. Yeah, so like here also we have this train folder, and inside that we have all our images, and there's like total of 25,000 images. Yeah, like so for the data preparation part, I did it on my computer and then saved all those files using Pickle. Um, yeah, so and then I uploaded these files to Google Drive, and that's why I'm using Colab now. So I'll be um, yeah. So I have those more yeah, training and testing data saved here, and yeah, the notebook as well. So yeah, I can import those data from Google Drive. Like I because I couldn't store the original data set in Google Colab itself. Like I couldn't do the pre-processing there. So for the pre-processing, I must use my computer. And yeah, so this is for building the dog and cat classes. Mm. And yeah, like whenever we want to run the model, we can just load all of these from the pickle files. And yeah, so this is one of the pre-processed images, and yeah, just visualizing that to check whether everything is working fine. And we have one hot encoding as well, and one hot encoding is very important to ensure there isn't any mathematical relationship that exists. Yeah, in case of label encoding, like 0 1 2, so here all the values are independent from each other. And yeah, we just need to combine the data from the auxiliary class as well as the dog and cat. uh, so for yeah, we need to like yeah, add them both together, and we have a total of 10 lakh yeah, 1 lakh 7,000 and 1,07,500 images in total. And yeah, this is like and then I need to shuffle them because like the first 8 lakh 75,000 yeah, the first 8 lakh 75,000 is the auxiliary class, and the remaining is cat and dog, so that's like an ordered way. So yeah, that's why we need to shuffle, and I just printed the first image again, and this time it's the image of a dog. Earlier it was an image of a man, and this is actually an image of a man holding a fish, but due to pre-processing it's hard to see. Yeah, this is the shape of our training data. Yeah, 1 lakh 7,500 images with all of 64 by 64 dimensions and RGB image. And the shape of our label is like 1 lakh 7,500 images. And like it's 3 because like it's 0 0 1 0 1 0. So yeah, its dimension is 3, the output. And yeah, I need to clear all these variables in order to save memory in Colab itself. Otherwise, like Colab will give an out of memory error. Like Colab has only 13 GB of RAM, but the GPU is much better. That's why I'm using Colab. And yeah, we need to ensure like here we have like 10,000 10,000 8 lakh 75,000 in the ratio, like cat is to dog is to others for training. So we must ensure the same ratio for test as well, and we can use this ratio for setting weights to our weighted categorical cross entropy, and that will be like 9.75 by 10. And so yeah, I'll just explain one. So the first one is like 1 is to 1 is to 8.5. So um, so for the positive case, we want to weight it by the number of images in the negative set. So that will be like 1 plus 8 9.75 by a total of 10.75. Yeah, that's literally what's happening here. um, yeah, we can use an array, and that will be much simpler to multiply across all the classes. And yeah, here I have defined my custom loss function, this weighted categorical cross entropy. And yeah, here I have built the model, like I'm using MobileNet and then copying all its layers and setting it to trainable. And I have added this final dense layer with 3 units. And yeah, the activation is softmax. So we have the training, and I use the early stopping, and early stopping will stop the model once our loss is minimized. And it takes about more than 2 or 3 hours to execute. Like the number of epochs will be small, like 80 or something. But since the data is huge, like each epoch will take a really long time to execute. And yeah, we have the learning curves here. Yeah, so yeah, our model will reach about 99%. Like this is the training accuracy, like really high training accuracy. Yeah, this is the learning curve accuracy versus epoch, loss versus epoch. Yeah, we can save the model. Yeah, that's a really good idea. And we can load weights from our saved model. That's good as well. So, and then we have to, now comes testing, and test in case of testing as well, we need to combine our data from others class as well as cat and dog. So here, in order to maintain that 8.75 ratio, I'll be selecting only 21,875 images from a total of 43,750 images. And yeah, this is the shape after plussing with 5,000. And we can test our model now, and we get an accuracy of 0.95, or like that is 94%, and our loss is 0.2. So that's actually really good, like we got 94% accuracy. And yeah, the predictions as well, like yeah, others dog others, this is the prediction, and this is the original test value. So others dogs others, yeah, seems good. And then this is the confusion matrix. So yeah, we have really good confusion metrics here. Like our true positives are really high, and the classification report. So yeah, like others class did have very significant F1 score, but our cat and dog classes have a good F1 score as well, like 0.84, 0.81. That's not bad. That's yeah, I think that's good. Like more above 80%. Yeah, so that's the classification report. Yeah. So yeah, our implementation is done, and yeah, I just like this is the amount of data available and the weights, pre-processing. Yeah, I have just put yeah. So without actually something that I observed was that without this weighted category cross entropy, we got an accuracy of 95%. So that's like 1% increase in accuracy, so or like 1% decrease in accuracy after weighing. But I think the weighted category cross entropy actually does better and will show much better significance when we use the complete ILS VRC dataset. So here I used only 1 lakh images from ILS VRC, but there's a total of 12 lakhs. So when we use those 12 lakh images, our weighted categorical cross entropy model can show a much bigger improvement. Yeah. Yeah, so I just put those table precision recall F1 score, everything for with and without category weighted weighing of category cross entropy or loss. And yeah, we got 96% and 90, approximately 96% and 95% with and without weighing of our loss function. And yeah, the limitation, as I kept on saying, was with the memory available, like our RAM as well as our hard disk. So like, yeah, I have just mentioned all of this here. So if I had more memory, I could have used all those 12 like images, and I could have used bigger dimensions such as 128 by 128 or 256 by 256. And these are all the research papers I referred, the books, and yeah, the images I took for equations of weighted and unweighted category cross entropy and all the data sets. And here you can view the implementation code. Yeah, let me just check this if it's working. I hope it's working. Yeah, so yeah, so that's my research paper. I hope you found it useful. Yeah, so yeah, the interactive Python notebook is loading as well. So yeah, everything is fine. Yeah, I hope you liked my project. Thank you, ma'am.